Welcome to our virtual workshop on data indexing. Uh, as it is, we as SubQuery have been supporting Archway for some time now. We have produced indexes, a query, a starter projects for the chain, and we've recently also got featured in Archway official documentation, which is just awesome. You should be able to find the link in the events info. And the goal of this workshop is to go in details of the quick start guide that are we referencing in the documentation. So let me touch upon the agenda. So first of all, going to be talking about problem discovery. What is the use case for index? Why does anyone read them? And then we're going to be switching to a solution that SubQuery is providing as an indexer, as a tool that essentially allows you to easily query data. Then we're having a demo time prepared. It's very beginner friendly. Hopefully we'll not have any issues when running our starter projects. But I've set up some safe environments first in advance so that we can switch to them if we're having some issues on the local environment. And finally, there is a time for the Q&A session at the end, as usual. So what challenges are developers facing? There are many types of developers, and probably the biggest segment is the dApp developers, and decentralized application is essentially a UI that is able to execute the transactions, and it also having some additional UI to present the chain state. So, for instance, any wallet is essentially a dApp. And every wallet is having a use case of showing your past transactions, and unfortunately, it's not possible with almost any blockchain to just input the address that you want to receive your list of transactions from, and just to fetch it. So that's why you need an indexer that will serve as a middleware for you, that will index all your transactions for you in advance, and then will serve the applications. And this is just one of the use cases. I'm not talking about the statistical metrics, for instance. As a dApp developer, you would probably be interested in your protocol statistics, and you want to have the, anything that's that associated with volumes or transactions grouped by certain period of time, such as a day, a minute, an hour, and that's where indexer comes in. So SubQuery is offering a end-to-end blockchain indexing solution. So first of all, it's a open source SDK that is very easy to use, that is having a lot of features that will not only simplify the indexing, but also not only limit you with its simplicity, but also can also give you the other use cases such as multi-chain. But I'll be touching on it a little bit later. When you are confident that your indexer is set up correctly, it's working locally, you would probably be interested in hosting somewhere. You probably consider Amazon or Google Cloud or any centralized solution. But from our side, we're also offering a managed services where it is which is again much easier to launch your SubQuery project that should just test it on the local environment. That's yet a centralized solution, but we have a decentralized marketplace as well. So essentially, it's a decentralized managed service where you can, where it's a network that is having its own actors, such as indexes that are indexing data, such as the consumers that are querying the indexes by different payment models, that way fetching the data from blockchain in a decentralized way. And there are also other types of actors like architects, delegators, and such. You can read more about on the other official website. So why SubQuery? First of all, it's completely open source. Everything is in GitHub. Everything is in the public domain. Even all the requirements regime, as well as the discussion and the issues. Secondly, it's very easy to use. So essentially, you can easily test your SubQuery project right on your local machine using a Docker by launching a single command. And I'm going to be showing you this command a little bit later during the demo time. It's simple, as essentially there are like 3 types of files that will have to be configured. That is the GraphQL schema, that is that will able to help you answering like what exactly you want to index, what exactly you want to query then. Secondly, it's a manifest file. Manifest file is just a manifestation of what exactly I want to index from a blockchain to consequently connect with the entities that I have derived in the GraphQL schema file. And finally, there are mappings files. Mapping files are the connections between the handlers and GraphQL. So they're just taking data that is being taken from in raw form from a blockchain. They somehow process it and save it as a GraphQL entity, so it is possible to query it afterwards. It's customizable. Again, every SubQuery project is a TypeScript project, and the sky is the limit to your imagination. You can do anything with that. You can even query the off-chain data and combine it with on-chain one. So very, very customizable. Finally, it's very fast with the help of different flexible customization on the indexer node itself, as well as the support of the dictionaries that are allowing you to pre-index the blockchain and query indexer, query dictionary instead of blockchain itself before trying to find a certain entity that the project is looking for. And recently we also launched a new version of SubQuery that made the indexing up to 2.8 times faster than it used to be. It's feature rich. There are countless common CLI flags for the indexer, for the query service. It's just a huge amount. Finally, real time. We'll be able to see from the logs that the data is being indexed in real time, and it is very easy to configure the debugging environment so that you have even more details in real time about what is happening with your indexer in this exact point of time. Then a very, very big feature that I've been previously touching upon is multi-chain. So from a single SubQuery project, it is possible to connect to multiple chains simultaneously. Not only the Cosmos chains, not only the chains from the single family, but also to chain from different ones such as Cosmos, Polkadot, EVM, and it is all possible from a single project. Then it's very flexible. So every component is reusable. For instance, the GraphQL query UI is coming out of the box, but you can easily replace it with different UI solution that you would like. So for instance, I was recently experimenting with Metabase, and if Metabase works better for you, that it's possible to switch. Finally, it's compatible with EVM, compatible with Vodun, and compatible with around 120 networks already. So I'll be gradually transitioning to a demo time, a starter project that we've prepared in advance. You can see the link to a GitHub right over here. So if you want to follow along, you can clone the project and start playing around with the starter project that we have created. You can also scan the QR code. Obviously, it's forwarding to the same link. Although you will have to have some prerequisites for your local environment. You will have to have the Vue.js installed. If you want to run locally, you'll need a Docker. From the Docker container from Docker Compose will simultaneously launch 3 components. First is a Postgres database. Secondly, it's an indexer and node. And thirdly, it's a GraphQL AUI. So Postgres database is being populated by indexer with this process data fetched from blockchain. And on top of this Postgres database, we're having a GraphQL that is allowing to query directly. Finally, you'll need a SubQuery CLI. So as I said, there are only 3 types of files. You are defining the shape of your data and want to index a schema file. You are configuring the endpoints and filters and smart contracts addresses or messages in a manifest file. And finally, you transform your handle data in the mapping file and save it as a entity that you've set in the schema file. So the goal of the demo is to index all Archway contract metadata and associated rewards paid out to contract creators. It was a no-brainer given the fair reward system that Archway is providing. So again, on the left-hand side, you can see a QR code to the starter project. And on the right-hand side, you can see a guide that is based essentially on top of this starter project. Those are interrelated from their contents. So be sure to check out both of them. So before I move to a demo, do we have any questions already? Okay. Right, demo time. So as you can see, I'm having my VS Code open, and that's an empty folder, and I'll be creating a scaffold. I'll be scaffolding a project from a template that we have prepared in advance. This template is the starter project that I've just been referencing. So, and that makes the onboarding to the indexer like very simple and very fast. You will see what I mean. So just to index a starter, just to scaffold a starter project for Archway, you will need to type a single command. It's SubQuery int. Obviously, you'll have to have the dependencies, the SubQuery package pre-installed in advance. So I'll need to give the project a name. But then from the list of available templates, I'll be able to choose the Archway starter project, the one that we've been talking about. I've chosen it, and now we're waiting for it to be fetched. Sometimes due to the network issues, it may take longer time for you. Anyway, we have successfully fetched it, and now we have provided a set of options. So the first option, the first setting is RPC endpoint. We can use the one provided by default, which is the one that you're seeing on the screen. And I can just actually select all the default values here. So once we have the settings selected, you can see that we have a new folder appear here, and we're having a set of files. And a first thing that you will have to do is to pre-install the dependencies for the project so that it works. And you can do it with a yarn install command. Oops. Yes. So it may take around a minute to be completed. So in the meantime, we can go through the files that I've been referencing previously. So we're having three types of files. We're having first a GraphQL that is a file that is allowing us to specify the entities that we want to make queryable. And in our case, we're only specifying two of them, which is a contract metadata and a reward withdrawal. So to get to populate these entities, we will need to look at the correct messages that are being in the blockchain. So we're going to be using a manifest file for it. So project.ts is a manifest file in our case, as is it the TypeScript project. So it's a TypeScript file. So let's just briefly go over the pre-configured settings. So we are indexing archway. It's a chain ID. So once we make the connection to the RPC, the indexer will compare this value with the one that is fetched from the RPC node, and if it matches, it will continue. Otherwise, it will abort. So that's the essential thing, and it's a safety feature. Firstly, then we have a endpoint object. So as you can see, that's an array. So you can simultaneously try to connect to multiple RPCs, and if one of them is not working properly, then the indexer will automatically switch to a different one. So we're having this endpoint as a default one. Then there is a chain types object. So chain types is something that is allowing us to manifest the messages, the types that we will be using to parse and decode the messages or the events we fetch from the blockchain. So in our case, we will need to decode this message, and as with every Cosmos project, those are being manifested in a protobuf format. So I'll be showcasing you the type generation a little bit later, but as you can see here, we're indicating the path to a protobuf file that we want to generate the types from. So in other cases, proto archway rewards v1 tx proto. So here we're having the proto itself, and for every project, for every use case, you may end up having like different proto files, and you'll have to somehow find it in a GitHub. So it's usually there's no like systematic approach to publish the proto files. So but it's usually published by the chain developers. So it was really hard to find it. In our case, we are using the protobuf that could be accessed from this repo. All right. So then, after chain types, we are manifesting the data sources. So we're indicating the start block. Start block is a start block is the first block that we're going to be starting our indexing from, and then the indexer will automatically iterate over all the next blocks one by one. So it's say we're going to be starting from the one of the earliest one from the was quite a long time ago already, but you obviously can like configure this value however you want. You can always even like pick up the latest block. Then we are having a handler subject. So handler is a function that is scanning a blockchain, and when certain conditions are met, that's when a certain event or transaction or block is being scanned, and it complies with the conditions, with the filters that we've applied to a handler, the handler will handle this function. So it will take its data, it will take this entity, this either block, event, message, or transaction, and somehow handle it. The handling itself is a different process. That's something that I'm going to be touching upon a little bit later. But just to make this like, just to make it based on the example, so here we're giving a name to the handler. The name is handle rewards withdrawal event, and if we open a mapping handlers file, you will be able to find the exact function. So this function will take a certain entity from the blockchain once indexer scans it, and will process it in a form that will develop it. And again, the whole development is done in TypeScript. Then there are several types of handlers, as I said. So for Cosmos chains, there are 4 of them. There is a block handler, there is a transaction handler, a message handler, and finally an event handler. So each of the handler types are having their own features and filters to be applied. But for this case, we will leverage both event handler and message handler. So to handle rewards being withdrawn, we will be using a data from event that is having this name. And for a set contract metadata, we'll be having a message that is having the same name essentially. Again, that's the second handler, and there is a different function for a different handler. And we end up with 2 functions in our case. It's a handle set contract metadata and handle rewards withdraw event. That's it. All right, so I've already talked a bit about the handler functions, but yeah, just to give more context, like what is happening on the level of a handler, we can take a look at this one, handle set contract metadata. So again, the indexer is checking whether there is a certain message there is a certain message appeared on the blockchain. So once this message is spotted, it's being fetched and handled. So we are passing this message as an argument to this function, and from this argument we're able to like process the message however we want. We can decode it, we can extract actually anything. So just to make a basic example, first of all, we are logging some, we're logging the block height just for the debugging purposes. Then we are creating a TypeScript object that is being automatically generated from schema GraphQL. So contract metadata in this case. Actually, I have forgotten to do something. I have forgotten to generate the types. So in order for me to do it, I have to type a single comment, a code gen comment. So if I type yarn code gen, I'll end up having a separate types folder automatically generated. It's having it will have like a different set of files depending on your configuration, but in our case we are manifesting two entities, and those entities are right under the models folder. So once this file is generated, you can import it. So as you can see, here it is, and we can jump to the definition of this class. So as a next step, we're trying to get the contract metadata entity by its ID. We are decoding the message and providing a contract address as an argument. What I mean by decoding. So as you can see here, we're having a MSG set contract metadata, which is an interface, and this interface is being automatically generated from this file. So essentially, what did the indexer do? So we have we asked an indexer to generate a interface according to the according to its specification, which could be found in this folder. That's it. And now indexer knows like how exactly the message is constructed, like what does it looks like, what objects does it have, and etc. So we can now decode it. And that's exactly what we're doing here. So we are decoding the message. We're taking the metadata object out of the decoded message object. And from the metadata, we're taking the contract address. If we were not able to find the contract metadata record, so if it's a first contract metadata with this contract address, we'll be creating a U1 using a create method. So we're populating it with various parameters such as ID, block height, created date, transaction hash, owner address, rewards address, and finally we just save it. And again, it's a single line of code, a single method, and yep. That's it. That's everything you need to run your Archway project. So we're now ready to run it. Again, as I said, the easiest way to launch the project is from the Docker Compose comment, as it will allow you to run simultaneously three components: the Postgres database, the node itself, and the GraphQL engine. I've done a pre-check, and it seems like the RPC node is limiting the amount of queries that could be done in a specified amount of time. So I'll be just minimizing the amount of data that we're querying from the blockchain in a single query, so that we don't receive a timeout message. So I'm just changing the parameters in the Docker Compose to workers are equals 1 now, so we're having only one worker, and we're only fetching the blocks one by one instead of 30 as we used to have before. So now I'm able to run the project. Here we have the list of supported commands, and the easiest way to run a project is by running yarn dev. Yarn dev will essentially do the code gen again. It will build the project, and then it will finally run the Docker compose file. So if I just run it, you're seeing that the code is being generated, the project was successfully built, and now we're having the Docker containers running. We'll need to wait some insignificant amount of time for it to be successfully launched. And there you go. We can see that the index already started to fetch the blocks, and the first one that was fetched is 1338, which is exactly the one that we've asked to start from here. And now we're able to query data. So your GraphQL interface will automatically pop up in on the port 3000 in case you haven't changed your Docker Compose config. And here you will see this interface and already prepared a query that will fetch the contract metadata that we've just saved, that we indexed and saved. So here you go. This is data that is currently being indexed, and obviously it will be only growing in sizes because we're only on the block 1000. There are still many to go. And let us try to validate the data that we have just indexed. So as you can see, one of the fields we index is the transaction hash, so we can easily check it in the blockchain explorer. I'm going to be using MinScan, so I'm typing the transaction ID, and here we go. Here is the transaction itself. Here's the message. Here are the details about the message, and as we can see, that's the type that we've been looking for. That's the type that we've put in the manifest file, and eventually that's the message type that we've handled and processed and saved as a GraphQL entity. And also here we're having a metadata object that we've obtained from a decoded message based on the types that we've just generated. Additionally, one cool thing that I wanted to show you are the aggregations. So again, here we are only indexing the, let's say, automized, not automized, atomic entities, atomic essentially properties. We're indexing the messages one by one, but you could also perform the aggregations on top of it. So for instance, you can, from the same GraphQL interface, you can also query and calculate the amount of those messages by an address, by reward address or by owner address. And in order to do it, you will have to enable a command for a GraphQL container that is called unsafe. Again, that's just for the safety reasons. Then we might need to relaunch the project. And another tip that actually I'm excited to share with you. It's not anywhere in the docs, but I'm using it daily. So as you can see, the data that you're indexing or that you're saving will be stored under that data folder. And if you wanted to completely reboot the project, you will have to delete this folder first. So you can do it with that command. And as a next command, you will just yarn dev again. So you will just again rebuild the project, generate the types, and run the Docker itself. Here you go. It's starting again now with the aggregations being enabled. Then we need to wait for a couple of seconds for it to successfully run. And yes, it has started successfully already. I already prepared a group aggregate query that will essentially group the entities by a certain property of the object. So in our case, we are calculating how many data points do we have with this owner address. We are first displaying its key, which is a address itself, and as the second object, we are calculating the distinct amount, the count essentially of those addresses. So as you can see, we already have 2, and obviously this number is going to be growing throughout the time. So that's actually all for demo time. So you're gonna follow along the guide that we've created. It's based on this exact example. We are getting into more details. What are we fetching? How exactly are we handling it? What is the process of type generation? And yeah, you can follow this guide. Additionally, there is a startup project that I've been sharing previously. And recently we were featured in the official Archway docs. And again, this is all interconnected, and all the links here are pointing to the quick start. And thanks a lot to Archway team for merging our PR very quickly and providing us a great feedback on its contents. Do we have any questions on demo? There may be any questions, maybe also some comments or feature requests, suggestions.
Hey, and Marius working with the DevX team, share the highlights. Thank you very much for this presentation. Great work. I don't have a query per se, but we're currently trying to identify some solutions to index some contract metadata. So I'll definitely look into with this presentation and try to replicate you did what we did, and we get it result. It couldn't take some, it was done, but I just wanted to say thank you.
Definitely, Mario. It's really truly appreciated. And here you can see the links. We have a 24/7 support in Discord for technical questions, or otherwise you can just reach out to me in Telegram. Right-hand side you can see a QR code.
Thank you very much.